Okay, let's make a program that utilizes command line arguments. All right, so I'll just make a directory and call it CLI args. We'll change into that. And in here, what we'll do is I will make a C file. Okay, so I have a template that automatically loads into any C file that I make. So what we'll do here is just say demonstrate how to use command line arguments. All right. Beyond that, defines. We don't really need any right now. We've got some standard libraries in there, not all of them, but some of them. But let's instead maybe focus on this part here. So in your main, you might look at it like that, but we'll have it like this. You'll notice that you optionally can pass in these arguments here. So here argc is an integer and argv is an array of strings. You can also, I don't know, maybe you like it like that, but you've got argc and argv. So argc is argument count. It's the number of arguments you've passed in to a program. And argv, which is a number of vectors of, it's a vector of strings that you've passed in. So it's all the different arguments. I guess the real question is, what is an argument? Maybe you don't really know, but let's just say, let's think about it like this. There's a program called echo in the command line, which you can just pass in a string to and it will echo it out. So you say echo hello and it writes hello. So let's try and recreate that. So but if you type in echo, this is my program, it'll also just echo out, that's my program. So we'll make a binary that essentially does the same thing. So let's go into CLI, cool. And we'll go down to the bottom. Let's center that up a bit. All right, so we don't really need an opening comment. It's not going to be that complicated. Let's just make an integer to count for us. Make a for loop really quick. I is equal to 0, I is less than, well, we're going to count up to argument count. There's going to be that many args, and we'll just increment by I. So we'll print out then the %s, and we want to access each string in, well, each string that is passed in, we want to print that out, but we also probably want to print a space after each string, because each string, so it separates as you pass in letters, words. Sorry, you'll get they'll be separated by strings. Spaces. This is probably best demonstrated by just me showing you. So, for example, let's actually go back in here. If you look at this and see what it's going to do, we can actually compile this. Okay, it compiles. I have a little script that does that. And if I go bin and I say CLI args and I just write hello, okay, you can see that it's echoed out two things. One is what I've actually written to run the program, and the next is the first argument. But you'll see that because I have separated everything with a new line character, if I write hello world, world will be on a new line. So what I was essentially trying to get at is that if you separate words by a space, they're a separate argument. All right, so maybe a real question is, well, what about hyphens? No, hyphens do not separate them into separate arguments. It's spaces, delimit is the word, the arguments themselves. So we have hello world, this is me, and we get like that. All right, so let's go back to our program and make some adjustments. We don't want it to print a new line every single time, so let's delete that. But we do want it to print a space, because if we, well, let's just see what happens when we don't have anything. Then what happens is when we run bin CLI args and we write hello world, this is me, you get a compacted version, no new line character, nothing. All right, so that's not what we want. We want a space, and we also want at the end, let's print out a new line. Okay, I didn't recompile. Classic problem. Compile. There we go. Hello world, this is me. All right, maybe we also don't want to print out the name of, or how we invoke the binary. So we'll just go into like that, go back in, and we will say I starts at 1. Okay, I starts at 1. We also need to recompile. Fantastic. Hello world, this is me. So we've essentially made echo. If you look at, if we did the same thing, but we just replaced the how we invoked the binary with echo, and we did the exact same thing. Hello world, this is me. Pretty cool, huh? So the interesting thing to think about is that you can change program behavior just by invoking the binary. So it means that you can essentially steer down a decision path or a process path just by invoking a flag, which is why things like GCC, where you can invoke the wall flag and the name the output file as my output binary, and then you can put in my input.c. It will then basically look for my input.c, and it can't actually compile because I haven't got a file named that. But you can see that these flags affect the program behavior. But we don't have to compile GCC again to get that behavior. It's quite useful. All right, so hopefully that was interesting. Until next time.